Hey kids, so we were talking about average unaverageness, right? Coming up with a number that tells us in general how much the data varies from the mean. Um, and when we did this last Tuesday, we we did this example with Jasmine, right? So we had 10 numbers. The average of the 10 numbers, 10 ages, and the average of the 10 ages is 41.5. So we calculated the standard deviation by doing a multi-step process, which basically the first step is calculate the mean. It was already done for us as 41.5. The second step is to calculate the difference between every number and the mean. So that's the step we did here. You'll see some of the numbers are negative and some are positive. That's what's always going to happen. And then on the third step, we square all those differences. And at that point, all your numbers are positive. And then the next step, we add those numbers up. Remember, I showed you this notation. This is saying to go from I goes from 1 to the size of the entire population, and xi means the position, right? So x1 would be the first number and x2 would be the second number, right? And we subtract it from the mean, and then we square it, and then we sum it up. And then our next step is we divide by the population size, and that gives us a number called the variance. And we won't really use that number in this class, although you might be able to be asked to calculate it in your homework. So it's just the second to last step of the standard deviation process. And the last step of the standard deviation process is to take the square root of the variance. So standard deviation in this case turned out to be 2.97. And you'll recall that when we started this example, we said that Jasmine has exactly 10 friends. So this is the population of her friends. But then we switched up the problem. Oh, before I tell you that, most statisticians would say that data that's within 2 standard deviations of the mean is those are numbers that are not far from average. Once you go past 2 standard deviations away from the mean, that is considered far from the mean. So our standard deviation was basically 3. So 2 standard deviations, or 2 times 3, is 6. So basically, if you add 6 to 41, you get 47, and if you subtract 6 from 41, you get 35. So that this is where statisticians would consider the data close to the mean. And it looks like all her friends are close to the mean because all of them are over 35 and under 47. Okay, and then the last thing we did is we talked about how the formulas is slightly different when you're using a sample instead of a population, right? So when you're using a sample, when you do that division step, you don't divide by the number in the sample. You divide by the number in the sample minus 1. But if it's a population, you divide by the number in the population. So we did this, then we did the same calculation, but this time we changed that assumption. We said, actually, Jasmine has thousands of friends. So this is a sample. This is a sample of 10. So we do the same thing. We get that same 88.5 sum, right? But then instead of dividing by 10, we divide by 9. And then we take the square root and we get a slightly bigger number. Okay, so let's do another one. I'm going to do it using a spreadsheet. and because I want to do 25 numbers. And when you have problems like this in your homework, it's not going to have 25 numbers. I think it's usually 6 or 8 numbers. But these are your grades as of 3 o'clock today, February 13th, in Lumen, sorted from least to greatest. And so I'm going to see if I can calculate the standard deviation for your grades. Okay, so the first thing you need to do is figure out what that average is, or what that mean is. So I'm going to write average, and I'm going to highlight these cells. And it looks like the average grade in the class is 39.725. Okay, so so that's going to be our mean. So our first step is to do x minus x. Well, I'm going to say mu, right? Because this is a population of our class. Every one of you is in here, so this is our population. So we're going to do a population standard deviation. So we're going to say equals this minus this. Okay. And now I've got the differences for all of these grades, right? So yeah, let me make sure we've got, yeah. Okay, so now the next thing we do is we square these numbers. So I'm going to say equal this raised to the second power. And here are the results. So as you can see, negative 3.125 squared is positive 9.765, and so on, right? And notice all the numbers are positive. So that is x minus mu squared, x minus mu to the second power. So now we're going to sum these babies up, right? If I sum these up, I'm going to get 22,000 basically. And by the way, if I sum up column B, I'm going to get 0. Hey, why didn't I get 0? Something is wrong here. Let me check the mean. Yes, I made a mistake when I calculated the mean. The mean should be of go to A26. So now this is the beauty of using a spreadsheet. Everything changes. Here we go. So here is the total, right? This is the total. I'm going to bold this so I don't forget that these are my totals, right? So this is why we have to square that difference from the mean, because if we don't square it, we're going to just get 0 when we sum them up. So now we get a large number, and now our next step is to divide that by the number in the population, right? So that's going to be our variance. So I'm going to take this sum, I'm going to divide it by the number in the population, which is 25. There are 25 of you. So that is your variance. And if I take the square root of that, that is going to be our standard deviation, equals square root of this, and it's 29. So that's a really big number. So that means that, let's see, if our mean is 41.176, then two standard deviations above the mean is going to be 41.7176 plus 2 times the standard deviation. So standard deviation is above the mean. The fence, I guess, the high fence is going to be 100.7. And then 2 standard deviations below the mean is going to be 41.76 minus 2 times the standard deviation. So yeah, so everybody's grade is close to the mean. I guess that's what this means, but so that's basically that's the idea. So you might want to like write steps out in your notes, you know, especially for your notes for the midterm exam, right? Because it's very easy to get confused when you have these multi-step processes. Find the average of your data, subtract each data point from that average, square that difference, sum all those squared differences up, divide by the population or the sample size minus 1, and then take the square root. And those are the steps for doing the standard deviation. Okay, and our last item is we are looking at the z-score. So the z-score is a number that we calculate for a data point of interest, right? So how far is a data point from the mean? So what we do is we take the data point value that we're interested in, subtract the mean from it, and then divide it by the square root. Sorry, divide it by the standard deviation, right? So that is going to tell us how many standard deviations a data point is from the mean. Okay, so here is our formula. X minus the mean divided by the standard deviation. So if let's say you are this person, your average in the class is 47.6. So you want to know how far you are from the mean. So I'm going to say, why don't I make a new column over here? I'm going to say the z-score. And usually you're just going to do this for one data point. I'm going to eventually do it for all. But the z-score is going to be this number. How far away is this number from the mean? And in this case, it's very important that you do the number that you're interested minus the mean, because you want to know whether or not it's above the mean or below the mean, right? So I subtracted from the mean, but then what I need to do is I need to divide by the standard deviation. So I'm going to go divided by the standard deviation, and that tells me that this number is very close to the mean. It's just it's 0.22 standard deviations above the mean. This guy here is 1.1 standard deviations above the mean, right? Because if you take 41.176 and you add 29.803 to it, you're going to get something a little bit smaller than 73.9. Let's see. Yeah, this is 70 is pretty close to 1 away from the mean, right? So this 0 is 1.38 standard deviations below the mean, and so on, right? So basically, to go back to the slides, if you want to calculate a z-value, or if you're asked to calculate a z-value, you want to subtract the mean